The next set of conversions we're going to talk about is mass to mole conversions. So just like a few minutes ago, we knew that 1 mole is 6.022 times 10 to the 23rd things, right? Atoms or particles. Now we know that 1 mole also has an amount of weight, right? We can determine how much it weighs. So we can use the molar mass to convert between moles and grams. So let's look at a couple practice problems. So again, whenever we do these, right, we're always starting out with what we're given. So we're told that there are 2 moles of carbon. Okay, and then I'm looking for grams. So how can I go from moles to grams? We're going to use our molar mass. So that means I need to think about, okay, what does carbon wrong number, 612.01. So carbon, right, has a mass of 12.01 grams. So when I go to plug in my train tracks, if I have moles on the top, I know I'm going to put mole on the bottom. And again, it's always 1 mole. And then I'm going to put the 12.01 grams on the top. So now moles have canceled. I can multiply everything on the top. I get 24.02 grams of carbon. Okay, which that makes sense. I know 1 mole weighs 12, so I know that 2 moles are going to weigh twice that. Okay, all we're doing is just showing our thought process there. Okay, let's look at the next one. I'm given 6 moles of water. Okay, if I have moles on the top, I know I need moles on the bottom. And what do I need in order to convert to grams? I need the molar mass, right? So I'm going to add up. What is the mass of water? So I know I have hydrogen. Hydrogen's mass is 1.01, but I have 2 of them. So I have to make sure I add that twice. And then I have oxygen, which is 16. Okay, so when I add all those up together, I get 18.02. So that is what is going to go in my calculation. Okay, that is the mass of 1 mole of water. So now I multiply the top, divide by the bottom, and you get 108.12 grams. Okay, let's look at number 3. Very similar, except for we're starting with grams. So I'm just going to write out what I have. Grams of copper. If I have grams on the top, I know I need grams on the bottom, right? How am I going to find the grams of copper, right, that are in 1 mole? That's going to be my molar mass. So I'm just going to look at my periodic table, and I'm going to find copper, and I'll show you what I'm looking at so you can kind of find it on yours. So mine looks like this, 63.55. So remember, that number is the molar mass. So all I have to do is just write it down in my problem. So then when I go to solve, remember we're going to multiply by the top, divide by the bottom. So I'm going to do 435 divided by 63.55, and that equals 6.85 moles of copper. So for number 4, okay, I'm going to let you pause the video, try this one yourself. Remember, when you're finding the molar mass of NaCl, right, don't forget you have to add those 2 together, okay, because you want the mass of that whole compound. So now I'm going to work it out. Always start with what we're given. 12.9 grams, right? So I know I have to have grams on the bottom because I had grams on the top. So I need to find how many grams are equal to 1 mole. So if I look at the periodic table, sodium is 22.99. Chlorine is 35.45. So if I add those up together, I get 58.44. So that is how many grams are in 1 mole. So now I multiply the top, I divide by the bottom. That equals 0.221 moles of salt. The last step, we're just going to put everything together into one thing, one calculation. Okay, so you can see here I've combined our 2 pictures. So we still have our 1 mole in the middle. Really, it's not moles, it's 1 mole, okay? And then we can either convert to grams, right? Using our molar mass, or we can convert to our atoms, or what I like to call things, right? Using Avogadro's number. So let's look at our first couple of practice problems here. So again, the rule, we always start with what we're given. Okay, so we're given 2.09 times 10 to the 23rd atoms, and this is nitrogen. What do we know about nitrogen? We know that nitrogen is a diatomic. It is part of that Brin-Klahoff. So we know that nitrogen is always written as N2. So I'm going to go ahead and write N2 so I don't forget. Okay, so I have atoms on the top. I know that I need to put atoms on the bottom. So what that tells me right away is I'm starting right here on my map. Okay, so I'm trying to get to grams, which is over here. So what do I have to do? I can't go straight from atoms to grams. I have to go through moles. So I'm going to go this way. Okay, so in order to get to moles, I have to use 6.022 times 10 to the 23rd. And remember, that number always goes in front of atoms. That's how many atoms there are in 1 mole. Okay, so now I'm at moles, right? I'm at 1 mole. Okay, so I've done the first step of my path. Now I need to convert to grams, and I'm going to use molar mass to do that. So I've canceled out my atoms. Now I have a mole up top. So if I want to cancel that out, I have to put a mole on the bottom. And then I need to find the molar mass of N2, right? So that's 2 nitrogens. So I have 28.02 grams of N2 is in 1 mole. Okay, so my moles have canceled out. So now I'm left with grams, which is what I'm looking for. So I'm all done. Now I'm ready to use my calculator and calculate my answer. So I'm going to multiply across the top, divide on the bottom. Again, don't forget, let me put these in a different color, to use your parentheses, right? Anytime we're using that 6.022 number, it's always a good idea to use your parentheses. That way your calculator doesn't get confused on whether or not you're trying to divide or multiply. So I'm just typing this in my calculator. You can also try to type it in your calculator if you would like. I get 9.72 grams. Okay, let's look at the next one. So again, we're starting with these formula units, which is just like our things, right? Our atoms. So this is where we're starting. So I'm going to go ahead and write that down. It's 10 to the 22 formula units. And again, this is NaCl. I usually like to write that down so I don't forget what I'm talking about. So if we have formula units or our things on the top, that means we have to have our formula units on the bottom. And remember, this Avogadro's number is what number goes in front of that, right? So 6.022 times 10 to the 23rd, and that's always equal to 1 mole. Okay, so now I'm here. Now I'm at a mole. And now I can take that last step to grams. So my formula units have canceled. Now I have a mole on top. I need 1 mole on the bottom. And then now I can use my molar mass to find the grams. So we did this one earlier. Sodium is 22.99, chlorine is 35. So that makes this 58.44 grams. So now, I'll use a different color again. We're going to multiply the top. We're going to divide by the bottom. But don't forget to use your parentheses. And I get 6.70 grams. All right, how do I know I have grams? Because all my units cancel. I'm looking for grams. Okay, let's try one more. And I think I'm going to let you guys try this one. And then we'll see how you did there. Okay, so I'm going to go through and set it up. You can watch what I'm doing and then kind of check yourself. And again, this is copper. Remember, I always like to write copper, write whatever it is I'm talking about so I don't forget. If I have atoms on the top, I know I need atoms on the bottom. So that's always going to be this 6.022, and that's always equal to 1 mole. So now I'm here. I'm ready to go to grams of copper. If I have a mole on the top, I want a mole on the bottom. And then copper has a mass of 63.55. So now I can multiply the top, divide by the bottom. Don't forget to use your parentheses. Okay, if you're getting numbers like times 10 to the 40 something, that's too big. So you should have got something like 127. Okay, let's look at number 4. I realize this looks weird because I changed something after I copied and pasted. So we are going to modify this one just a little bit. So it says a sample of H2O, water, okay. We have 40.9 grams. and I want to know how many molecules is this. Okay, so I want to look for molecules. So this time we're just going to go the opposite way, right? So I'm going to start with what I have, grams of H2O. Okay, so this time I'm starting here with grams, and I want to get all the way to my things, so I have to go across. So I get to moles first. How do we convert to moles? We're going to use molar mass. Okay, so if grams is on the top, I'm going to put grams on the bottom. And then remember, how do we find molar mass? We're going to look at our periodic table. So if you want to, put a little PT right above this molar mass, so you know that's where you're going to look for that, right? So we're going to add up 2 hydrogens, 1 oxygen. We get 18.02 grams. So now, whoops, I don't know why I put that on the top. 18.02 grams. There we go. And that's equal to 1 mole. So now my grams have canceled, and now we have moles. Okay, so we're just moving along in our path. Now we're ready to go to atoms. Okay, so if I have moles on the top, I want mole on the bottom. And then when we start to write our molecules, remember our Avogadro's number always has to go in front of our things, because that's telling us how many things we have in our 1 mole. Okay, so now my moles have canceled. I'm left with molecules, which is what I was looking for. So now I'm going to multiply the top, divide by what's on the bottom. And you're going to get a big number, and that is okay. You're supposed to, because remember, we're talking about molecules, and molecules are teeny tiny little things. So we expect to have a lot of them. Okay, so something like 1.37 times 10 to the 24th. So that is all there is for these notes. So now your goal is to start working on the case. Okay, you have learned everything you need to so far to get through all of part 1 on the case. I do have a little hint down here for you. I have numbered the steps in the case to match with the steps in our notes to kind of help you if you get stuck or if you're not sure what exactly you're supposed to be doing. Okay, so use your notes to kind of help you work through each step. You do have to go in order on the steps or on the case, because you'll need kind of the beginning information to work you through the other parts of it. Okay, and then if you have any questions, feel free to ask me. And then you're also, if you need to work with a partner some and kind of help each other out, that is also perfectly fine. And good